My name is Epic Rant. You've seen me in such fine quality chemistry educational videos as Smeagol of Stoichiometry and Precipitation in You. Okay, we're going through some stoichiometry precipitation problems. The general idea is that we take two chemical compounds, mix them together, and find out is there a precipitate that's forming. Now in this case here, for these two problems, we're already assuming a precipitate is going to form based off of the solubility rules. Let's go ahead and take a look. So what mass of solid is formed when 100 milliliters of 0.100 molar barium, Patrick, chloride is mixed with 100 milliliters of 0.1 molar sodium hydroxide? Okay, so when we have a question like this, the first thing we want to do is let's write out the equation. Okay, well, what is barium, Patrick, chloride? Well, barium chloride, that would be BaCl2, and we are adding NaOH, that would be our sodium hydroxide, and we would get some kind of a result. Well, hey, what would that result be? Well, it would be BaOH2 plus 2NaCl. So that's what our reaction, our chemical equation is going. I only do this in one take. So barium chloride, sodium hydroxide, we get barium hydroxide out of this, and salt. Now the truth of the matter is, are we worried about the salt? Smeagol says no! Right, Smeagol, good job. We don't have to worry about the salt, but we are interested in the barium hydroxide. So, what mass is solid? Well, what's the solid in this case? The barium hydroxide, Patrick! Okay, so now we've got our equation set up. Now let's see if we can go and figure out what other pieces of information we're given. We have 100 milliliters, okay, so we have 100 milliliters. If we're going to deal with concentration, what are we going to need to do with milliliters? That's right, we got to change that to liters. So I'm going to go ahead and I'm going to change that to liters right now and say 0.1 liter. Okay? How did I get there? How many milliliters are in a liter? And then you go on from there. Now, we also have a concentration of 0.100 molar. So we're going to put that in, 0.100 molar. Okay. So that's the information we have for our barium chloride. Let's take a look at the sodium hydroxide. They gave us the same thing. Notice they also gave us 100 milliliters. Isn't that nice? They gave a nice round number. Okay. So again, we can convert it to liters. And again, nice of them to give us our concentration. That is a capital M, ladies and gentlemen. Okay, remember molarity is always a capital M. Wow. Okay. So what in the world is going on here? Well, we need to figure out how many moles of barium hydroxide are going to be formed. But we don't know. They gave us equal amounts of BaCl2 and NaOH. The thing comes down to is this equation balanced? No, it's not. And that's a very important thing to look at. You always need to balance the equation. Okay, how do we balance this? Well, in this case here, we're going to need to put a big old 2 in front of the NaOH. Why? Well, because the OH has a -1 charge to it. Ba, the barium, Patrick, has a +2 charge to it. Okay? So this is what we have. So this is balanced. Now, do we have a 2 NaCl? Yeah, because we'll have 2 sodiums and 2 chlorines, and that gives us 2 NaCl. But we don't care about that, Patrick. Okay? Maybe you're not picking up what we're laying down here, Patrick. It's really simple. Does the NaCl create a solid mass when we mix the chemicals together? And the answer is no, it doesn't. It doesn't. Okay. So now that we've got that straightened out,
we need to figure out how many moles of NaOH and how many moles of BaCl2 that we're going to have. The 2 does not take place right now. That coefficient doesn't matter. Is it going to affect the problem? Yes, but not when you're calculating the moles here. That's a very important thing that you need to pay attention to. Okay? So, let's deal with this. What's the formula for molarity? So, well, molarity is equal to moles over liters. Now, could it be less than 1 mole, greater than 1 mole? Yes. Could it be less than 1 liter, greater than 1 liter? Yes.
Can Smeagol write this into milliliters instead of liters?
No, Smeagol.
Why not? Smeagol likes milliliters. Smeagol likes stoichiometry too.
Because if we do it in liters, and if we do it in milliliters instead of liters, then our numbers are going to be off. Okay? And you need to pay attention to that. You always want to change this into liters. If you notice, that's how I changed it in the first place. So let's figure out how many moles of barium chloride. So, moles of barium chloride. Well, the moles is going to equal the molarity multiplied by our liters. Okay? So that's just, we went for that logical progression here. Okay, and now, well, hey, we got our molarity right here, and we have our liters. So guess what? We can figure out the moles of barium and the moles of the NaOH. So I'm going to separate that there, because now we can figure that out. So for 0.1 liter multiplied by 0.1 molar, okay, and that's going to get us 0.01 moles of barium chloride. Okay? Hey, Canu, I got rid of the barium. How'd you do that, Dono? I simply buried the barium. Okay. So that gives us the moles of barium chloride. Great. What about the moles of NaOH? Well, same thing. If we look up, we have 0.1 liters multiplied by 0.1 molar, okay, and that's going to give us 0.01 moles of NaOH. So now we figured out the number of moles. Now remember, what's a mole? A mole is a number, and that's what we're interested in. What's going to run out first? The sodium hydroxide or the barium Patrick chloride. Okay? And if you're wondering where Patrick comes from, you have to look up the Lutheran satire videos under Donald and Connell. You will find Patrick there. Okay? Okay, now we got the moles of both. What's next? Well, now we have to figure out which one's going to run out first in this reaction. And that we would have to go back to our original equation. So I am going to go and work with the barium chloride first. So I know that for every 1 BaCl2, our barium chloride, we're going to have 1 barium hydroxide. Okay? That's what we're going to have. Okay. That's according to our balanced equation. If we look up earlier, if you look up, why is it doing this? Go. Oh, goodness. If we look at the original equation here, for every 1 of these BaOH2s, we get 1 of these BaCl2s. Okay? And I will refer to you again when we do BaOH2 to 2 NaOH. So I don't have to go up the screen again. Okay? So if I have 0.01 moles of BaCl2, okay, how many moles of BaOH2 are we going to get? Okay? And the answer is, if we ran this thing all the way through, that is annoying. Really. Seriously annoying. No. Okay. Okay. I'm working with technology that sometimes it does weird things. All right. So what does that mean for us? That means we would end up with 0.01 moles of BaOH2 if we ran the product all the way through, if we ran the reactants all the way through. Now we're going to do the same thing, except we're going to use the NaOH. Okay? But what do we know about the NaOH? We know that there's, for every 2 of these NaOHs, we're going to have 1 BaOH2, like this, 1 barium hydroxide. Okay, and again, based on those earlier calculations, okay, and hopefully you've been writing this down on paper because I'm afraid to go back up with this board going crazy on me. Okay, I know we have 0.01 moles of, NaOH, okay, over X moles of BaOH2. Now we solve for X. The nice part about this is, ladies and gentlemen, that we would end up getting 0.005 moles of BaOH2. Okay. So that means either the barium chloride or the sodium hydroxide run out first in the reaction. Which one's running out first? It's our sodium hydroxide. Well, why? You had equal amounts. But remember, it takes 2 of these to make one of these happen. If I have the same amount of this as the barium chloride at the beginning, Patrick, okay, I'm going to run out of this. So this is going to be my answer in terms of how much barium hydroxide am I going to get out of this, my precipitate. Now, final thing, because they're asking us how many grams of this stuff are we going to get? Well, now that we have moles of this barium hydroxide, now we can go from moles to grams. We're going to multiply. Okay? Now, how are we going to multiply? Well, we have to figure out how many grams per mole there are in BaOH2, and I'm going to go ahead and write that up so you guys can see it. Okay, Ba is 85.47. The 2 oxygens is 32 even, and the hydrogen is 2.02 together. So we have 119.49 grams per mole for the BaOH2. Okay, now let's move on. As we do this, ladies and gentlemen, now we have our moles. So our last step. Can you imagine this? I'm so happy. 0.005. Pay attention, Patrick! Okay. Our last step. 0.005 moles multiplied by 119.49 grams per mole. And our final answer, here it is, 0.597 grams. And there you have it. There you have it for the first one. Can you imagine that? Wow. And you know what? I'm going to break this video. I originally was going to do it in one thing. I think I'm going to make it in 2 separate things. So, at this point, ladies and gentlemen, we have found the solution for that one thing. We go back, if we were to go back to the top, okay, if we went to the view and did the zoom, uh-oh, I think my thing is off. Let me check. And, okay, nothing there, try again, okay. Let's go back to 50%. Okay, so now we have it at 50%. We have our equation. We figured out how many moles of the reactants that we have, okay? And we calculated it, moles over liters equals molarity. And then we multiplied how many moles of barium chloride and NaOH. Then we had to look if we ran the reaction where one reactant was in excess, okay? This is what we have here. This is what we did. We ran it that NaOH was in excess. Here we ran it as in BaCl2 is in excess. So we figured out how many moles of product that we have. So we end up getting, we take the lower number of moles in order to do this. Then, once we figured that out, ladies and gentlemen, once we did that, then we went from moles to grams, you multiply, okay? We added up how many grams there are in a mole of BaOH2, multiply by the number of moles that we got from this step to get 0.597 grams. Hey, I hope this has helped you guys out because, you know, this is out on the internet. This is Epic Rant signing off. Patrick!